So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it.
Welcome back. Today we are working on Unit 2, Lesson 2. Our aim for today is going to be how do we use proportions to solve problems. Right now we have a warm-up, solve the following, show all steps. It's 3x equals 6. So this is just a review of 6th grade material. We're going to solve. So 3 and x are connected through multiplication, so we have to take the inverse operation. So we're going to divide by 3. Your 3's cancel out. You're left with x on the left. You want to do the division on both sides and say 6 divided by 3, which is 2. So your answer for x would be x equals 2. Now we're going to use this knowledge that we have from 6th grade, and we're going to apply it to set up and solve proportions. So the first thing you want to do in order to set up a proportion, you want to label the top of the fraction with the same unit. Then you want to label the bottom of the fraction with the same unit. Remember, proportions are two fractions that are set equal to each other. And then you want to solve by cross multiplying. So cross multiplying would be when you multiply A times D and then B times C. So you multiply diagonally across your equal signs. All right, so let's try this out in the first problem. You have 1 1/4 over 2/3 equals x over 1/2. Now we're going to use our strategy on our left. We have it here, just as a reminder, and we are going to cross multiply. So that means 1 1/4 times 1/2 and 2/3 times x. So 2/3 times x equals, I'm going to change this 1 1/4 to 5/4 times 1/2. So what I'm going to do first is I'm going to multiply my 5/4 and 1/2. I'm going to get 5 over 8, and that's still set equal to 2/3 times x. Now, if we divide by 2/3, we're really just multiplying by the reciprocal, because eventually these will cancel out. 3/2 and 2/3, they cancel. So if you multiply by 3/2 on that side, you have to multiply by 3/2 on the right. So you get x equals 15 over 16. And you can't simplify that, so that becomes your answer. So x equals 15 over 16, or 15/16. All right, let's try number 2. So number 2, we have a word problem. So here we have to pull out our information and still set up our proportional relationship and our proportion so we can solve it. So we have it takes 20 minutes to skate 4 1/5 miles. How many miles can Danny skate in 30 minutes? So I'm going to stick with my time. They're in the same color. And then I'm going to justify, could Danny skate at least 12 miles in an hour? And we're going to see if that's so. All right, so what I'm going to first do is step 1 is label our top number, our numerator. I'm going to label it miles. And then the bottom number, I'm going to label it minutes, or it would be time. So I have my fractions. I'm going to say my miles, I have 4 1/2. I'm going to change that into a improper fraction. So I'm going to do 21 over 5. And then miles, we don't know, we're trying to figure out. Minutes, it takes 20 minutes to skate the 4 1/5 miles, so 20 minutes. And you want to figure out in 30 minutes how many miles Danny can skate. So we're going to cross multiply 21 fifths times 30 and 20 times x. So 20x, I always want to leave my variable to the left. Makes it easy for me when I'm solving it, but it's your preference. 21 fifths times 30. So if I get 21 times 30, I'm going to get 630 divided by 5. 630 divided by 5, I'm going to get 126. Remember, 20 and x are connected by multiplication, so we're going to separate that by division. I'm going to divide by both sides. X is going to be 6 3/10 miles. So if you think about it, when I'm justifying my reasoning, if I am figuring out that Danny can skate 6 3/10 miles in 30 minutes, if I'm trying to figure out an hour, really an hour is 60 minutes, which is doubled for the 30 minutes. So I know 30 minutes is 6 3/10. If I multiply that by 2, I'm going to get 12 6/10 of a mile in 60 minutes. And that means, yes, Danny can skate at least 12 miles in an hour. Okay. So for the last question, try it on your own. Number 3 and 3A. Pause the video and we'll come back and check it. Okay, so here we have a mix of sugar. We have vanilla and flour. So we have a ratio of 20, 18 ounces, and then 12 ounces. When Alex makes a larger batch, she uses 30 ounces of sugar. How many ounces of flour would be needed? So we are focusing on the ounces of flour. So let's set up a proportion. Let's say sugar, and then flour is the bottom. Okay. So we have in the original, the sugar is 20 ounces and flour is 12 ounces. We know that she's going to use 30 ounces of sugar, and we want to figure out how many ounces of flour would be needed. Let me highlight this so I can see that. That would help. Okay, so what we're going to do is we're going to cross multiply, so 20 times x. I'm going to keep my x to the left. And then I have 12 times 30. Cross multiplying. So 20x equals 360. Remember, we want to it's connected by multiplication, 20 and x, so we want to divide both sides by 20. And you're going to get x equals 18 ounces of flour. So that's the answer to 3. But now, would the relationships remain proportional if the batch was cut in half? Explain your answer. So, if your batch was cut in half, all of your ingredients would be cut in half. So yes, because sugar, vanilla, and the flour ingredients would be cut in half. So if the batch was cut in half, so would your ingredients. Okay. So now, if you're in class, make sure to continue to complete your independent work. And if you're at home, make sure you're going to Google Classroom for your assignment. Thanks for watching, and I'll see you guys in the next video. Bye.